Okay, do we want to start like me presenting Diego while people join to listen to the interesting part of the chat? So let's do that, right? And I'll stop, then you can add something if you want.
Actually, I believe you can present Diego.
Sure, let's do that. Well, first of all, Ivan asked, he said he apologized he couldn't make it to this call, but he's very well aware that we are having it. And I'm speaking on behalf of him, and Ostap will as well. We are presenting Diego, and it's the first of, we hope, a long and interesting set of knowledge sharing sessions that include, like us now being Avenga Latam, are starting to take, are starting to have, like, together with Avenga, like, worldwide. Diego is going to present about continuous performance. He's been in Include for a long time, like 10 years. He's a technical lead, and he's going to present himself later, but he's knowledgeable and certified on performance testing on top of other things. But just for the purpose of this meeting, like, bear that in mind. This training was already given in Spanish last week at the office. We didn't want to spoil, that's why we moved it so that it was later than that. But it was in person. We had people outside of Include participating. It was open to the public, and he did a great job. So I'm sure you'll do it again, Diego. Congratulations for being brave and being the first of us to present in this. So thank you very much for that. Ostap, do you want to add anything, or we can now let him start?
Yeah, let's start.
Do we start? What's the Kensia? Is that your name?
I think we're on time to start.
Yeah, let's start. We have 83 people. Thank you for joining, guys. You'll enjoy the call. Diego, let's go ahead.
Thank you for the presentation, Ariela. Well, first of all, I want to thank you all for joining to this meeting. Today, as Ariela said, we will be talking about continuous performance testing. But I'm going to give a brief presentation of mine. As Ariela said, I've been working for Include for about 10 years, but I have 14 years in QA. Before of that, I was a PHP developer. I did some certifications, Oracle database, Cisco networking, and so on. But because of a need, I started with QA, and I really like it. That's why I focused my career in this path. That's why I did a diploma in software quality in the university. After that, I did some certifications. I did ISTQB foundation level, CMAP. CMAP, it's a mobile application for testing. Because it's no longer available, because it was moved into the ISTQB 3 of certification. Now you can find it there. And in 2019, I took the exam for performance testing, ISTQB, and I really like it. I did this certification without any experience. I just did before a couple of scripts, but not something very important. And I really like it. That's why in the following years, I've been working doing performance testing as well as test automation and manual testing. And during that time, I was reading articles and publications about performance. And that was the moment when I first heard about continuous performance testing. After reading about it, I realized that if we had applied it in our project, we would have arrived at the release with more peace of mind. That's the reality, and that's why was my idea to bring this tech talk. And well, in my free time, I play the bass guitar. I have a band. I play in a band, and I'm pretty sure that there are more musicians here. There is something about music and software engineer. I don't know what is it, but I'm pretty sure about that. So, well, I'm living in Cordoba. Cordoba, it's a city that is in the middle of Argentina. And I really like it. So you are all invited to come here whenever you want. Okay, let's talk about the agenda. First, we are going to be talking about some basic topics. What is performance? What is performance testing? We will talk about simulations, tools, type of performance testing, and where to put the focus on performance. After that, we will be talking about continuous performance testing. We will see how we are usually testing performance right now. We will talk about continuous performance testing, shift left, shift right. And at the end, the last part, if I have time, we will talk about K6. I'm going to give you a brief introduction to this tool. And I select this tool because I think that this tool fits with all that we're going to see in this call. But well, it's not the only tool that we have for doing this, but I really like it. Then I'm going to show you why. So let's get started. Let's talk about some basic topics. Well, the first thing we think when we think about performance is in response time and throughputs. Throughputs are the number of requests per second. But imagine the following situation. Imagine that you have an application that at a certain load that you're testing, the response time is good, the throughputs are fine because they increase while you were increasing the load of the system, but the CPU is over 90% of consumption, or the memory is over 90%. We cannot say that this application is have a good performance, because we know that the application is not far for a breakpoint. So take this into account when we talk about performance. We are not only talking about response time and throughputs, we are also talking about resources consumptions. And how we test performance? Well, I put here 3 points. Simulations, we will talk about this, but later. But well, what we do is to create virtual users that are going to hit the server, simulating that our user using the system. Similar to automation, but have some difference. Then we will talk about it. Monitoring, because we need to do monitoring to see where is the bottleneck, where are the breakpoints, the memory leaks, and so on. And lastly, optimization, because when we found something, we should work on it and try to fix it, or in order to improve the performance of the system we are working on. And there is something about monitoring that I want to clarify, because for me it's really important. When we talk about monitoring, we are talking about not only our side where we are seeing the response time, the throughputs, and all the statistics that we can get from our side. We also should be monitoring the servers. And in many cases, we don't understand what is happening behind the servers. That's why we need to call DBAs to do the monitoring of the database, DevOps to check the servers, the backend server, the application servers, and so on. And the architecture, team leaders, technical leaders to try to find where is the issue. So basically, performance testing is not an isolated task. It's a collaborative task. That's why I like to say that it's a multidisciplinary activity. And the good thing about this is that when we are in this process, we learn a lot about different parts of the system. We learn about database optimization, we learn about networking, we learn about server configurations, and so on. So performance is a window that show us a lot of things that are really interesting in our development. Let's talk about simulation. As you can imagine, well, here in this graphic, we have this person who is running from his computer, have 3 different nodes, and each node have this robot. Imagine this robot like virtual users. What we are trying to do here is try to emulate the behavior of a person in front of the system. That's what the virtual user does. But this is not very, it's similar of test automation, but it's not the same. In test automation, the scripts we create, we just try to make it run as fast as we can because we want the result and that's our goal. But in this case, we should simulate the behavior of the person, including the think time, the time that takes to the person to fill a form, to move the mouse, and so on. So, and sometimes we have the statistic from Google Analytics where we can analyze the behavior of a person, but that's the idea, and that's part of the differences between a script for test automation and performance. So in each node, this person have a lot of virtual users. Maybe we can have 200 virtual users hitting the server at the same time. And the idea is in test in performance is that the script is not executed just once. It's going to execute the script every virtual user, and at the end it's going to execute it again, and at the end again, because the goal here is to maintain the concurrency of users along a period of time. Then we're going to see in different performance testing types, but that's the main idea. So we have a lot of virtual users here in the server, and here we will need people doing monitoring of what is happening behind in the database network, backend server, load balancers, and so on. So this is what we do. And how we do it? Well, we have some tools that can help us. There's no doubt about that JMeter is the most used in the market. It's an old tool, but it really works. It's an open source tool and have a lot of plugins that allow us to do almost whatever we want in performance. Then we have LoadRunner. LoadRunner is not open source, it's a paid one. It's expensive. It's a huge tool because you have to install more than 3 gigabytes in your computer. And it's not one application, there are 3 applications. Virtual User Generator that help us to create the scripts. The controller, the one that we use for the execution, and the analysis is the one we create the reports and we can do the analysis of what happened during the execution. Then we have Blazemeter. Blazemeter is a tool. It's more than a tool. It's an infrastructure for performance. You can run scripts from JMeter, Gatling. Gatling is another tool. But the good thing about Blazemeter is that offer you a whole infrastructure to execute your performance test. For example, you want to test people connecting from Japan, Canada, and Australia. Well, you can use this tool to do this kind of testing, the performance testing, and you can also set the bandwidth, the device that the user is using, and so on. It's very similar to Flood. Flood also allows to run JMeter scripts and Gatling scripts. I'm not very familiar with this one, but it's very similar of what Blazemeter offers. And the good thing of Blazemeter is that you pay for the time you use it. So it's very interesting. You can create your scripts in JMeter, for example, and then execute it as you need in Blazemeter. JMeter doesn't have this infrastructure to execute it, and you have to create your own one. And lastly, we have K6. K6 have both parts because it's an open source tool, but also have a cloud version that allow you to do this kind of executions and give you facilities in reports. Then we will talk more about this one. Well, type of performance testing. This is just one of the classification of type of performance testing. We have another classification that talk about static test and dynamic test. This means that in the static, you check all the documentation of the infrastructure, architecture, database before they are implemented to try to find possible issues in performance. And then the dynamic one is the one that we usually use. But now in this type of performance testing classification, we're going to talk about this. Load testing, endurance, stress, and peak. The difference between them, you can see here that in vertical, we have the number of virtual users along the time. When we do load testing, what we're looking is bottlenecks. That's the objective of load testing, find bottlenecks. And as you can see, we have a ramp up, then we maintain the load, and then we do the ramp down. This is very important because when you run performance scripts, you don't have to send all the users, virtual users at the same time. So you have to do it in this way because this is more realistic. If you do it all at the same time, maybe you're going to collapse the server. So, and this is important. The load testing lasts more or less 1 hour, 30 minutes, maybe sometimes 10 minutes, because it's going to depend on the type of application you are testing. Endurance testing, it's similar, but use a lower load than in load testing. And the goal here is to find memory leaks. How it works? We execute the test, but for a long period of time, because what we are looking here is try to see if along the time we have degradations in response time or something. Maybe some database are not being closed, and after a while they just collapse. Well, this kind of issue is what we are looking here. Here said 5 hours. In different projects we did execution of 12 hours, for example, a whole night. But well, that's the goal of the endurance test. Then we have stress testing. The goal here is to find the breakpoint of the application. And again, we do it like a stair. We increase the number of virtual users, then we maintain that number of virtual users because we wait for the server to be stabilized. Then we increase again, we wait again until we get to the breakpoint. And peak test. This is very simple to explain. Imagine that you have an application that belong to a company that have 1,000 users that they logged in the application at 8 a.m. Well, we know that the traffic that is going to generate in that moment is not going to be along the day. It's going to be just the login at that moment that is going to be we have a lot of concurrency. Well, that's an example of when we have to test peak test. We know that the login at 8 a.m. is going to be with a lot of connections, and that's what we have to test. For example, a marketplace imagine Cyber Monday, Black Friday, those kinds of events that they're waiting for a peak of connections. Well, those are the scenarios that we have to test with peak test. In the last projects I've been working, it was not needed, but we have to take this into account. And where's the focus? As you can see, we were talking about hitting the server, right? We talk about using simulations, we talk about some tools, we talk about the monitoring with application performance monitoring tool, metrics of the operative system, and so on. But this is not the only place we should look for performance issues. We should have also to take into account the network, the traffic capacity. Imagine that we are executing our script, but the connection we have is not good. Maybe the bottleneck is in our connection and we are not hitting the system as we should. Take into account the load balancer, for example. It happened something to me in a previous project that we were generating load to test the performance of an application, and the response time was not the expected one. And then we found out that the load balancer was redirecting all the traffic I was generating to a particular server. And that was not wrong. That was good, because imagine that I'm trying to turn down the server, to shut down the server, and I'm attacking, I'm a hacker and I'm attacking this server. Well, the load balancer redirect everything that comes from the same IP to the same server. But for performance testing, that doesn't work. So I have to ask to change that configuration, to execute our test, and then revert the configuration just to leave it like it was. Those kind of things are the things that we have to take into account. So not only the server, also the networking. Or imagine the CDNs. I didn't have to work with this, but these are caches that are located in specific places. Imagine that you have your servers in the United States and you have people from Japan that access to your application. You can have a cache in Japan, so you make faster the connection for the people from there. So if we are testing performance, we just have to take into account those kind of things. And lastly, the client side. It's something that I guess that not much people talk about it, and it's one of the most simple things to test. Here I include two different applications, PageSpeed and Chrome Lighthouse. PageSpeed, it's a web page where you introduce your URL and give you the information of the performance in the client side. And Chrome Lighthouse is something that everybody has because it's in Chrome. You just have to press F12 and look for Lighthouse, and then you can generate a report from there. And what kind of issue we can find in the client side? Well, there are many issues that we can find in the client side. Maybe you have a server that works really well, the performance is great, but the page takes time to load. Well, something that we can find there is, imagine that we are sending an image to the front end, a huge image, and we are doing a resize on the front end. We are sending a lot of bytes unnecessary to the front end, and we are generating more traffic. So that's one of the kind of issue that we can find on the front end, on the client side. Another one is maybe we have some JavaScripts that are not being used, or maybe some synchronization issues. Well, this kind of bugs we can find on the front end. So take this into account when we talk about performance. We are not just talking about server, the network, we're also talking about the client side. We can find these issues everywhere. And for mobile, I didn't have the chance yet to do it. I know that there are some applications that test the performance of mobile applications, but what I used before is the Android profiler in a project where I can see how the resources that was using on the client side an application. And then for iOS, we have Xcode instrument that also provide a tool to check the performance of the devices. So those were the concepts that I want to review first before talking about continuous performance testing. How we usually test performance. I'm not saying that everybody do this, but in almost all the projects I experienced this. Everything goes to agile methodologies. So we are working differently with this last 15 years, but something that we still working as waterfall is performance. We are still waiting 1 month, 2 months before the release to start doing performance testing. And that can lead us to have issues that we cannot fix in that instance. It happened to me. We have some database issues because the database in the design was not right. And we cannot fix it because we cannot change the database at the end of the release. We have to change the whole backend. So imagine that situation, we just have to live with that. And that's happened because we wait for the release to do performance testing. The purpose here of the continuous performance testing is to take the DevOps approach and do shift left and shift right. And when I'm saying shift left and shift right, I'm not saying that we should move the performance to a side or the other. The idea is to expand the performance testing. Shift left means early stages on the development cycle, and shift right could mean also testing on production. I know that sounds controversial, testing performance on production, but then we will talk about it. We know that test early and test often should be our goal always, because we know the benefits of doing this. So let's talk about shift left. Start early, we have early feedback, and we can take actions early in the project. Test frequently will give us also the chance to optimize learning. What I'm trying to say when I say optimize learning, imagine that we found something in an early stage in the development, and we raise our hands, and the developers take time to do a research about how can fix that issue, that problem. And we know that the developer is not going to spread that issue all over the system. But if we don't find it earlier, they are just going to be doing the same, because it's the way that they know how to work. So the idea here is that if we find issues earlier, we are also going to optimize learning, and we will learn, and the developer will learn how to improve the performance or take into account performance from the beginning. And which type we use on this, there is an error, I should say shift left, sorry for that. What type of performance testing we're going to do is load testing. Imagine that we can start doing this when, for example, when an endpoint is finished, we can create a short script that tests that particular endpoint, and we can put it on the pipeline. If we do that, we will see along the time the changes in the response time. So if we see a degradation in the response time, then we will know when was the moment that started happening, and we can see what was the problem. Maybe it's something that we can fix, maybe it's something that we cannot fix, but at least we will know when start happening. So that's the idea of the shift left. Every time that we have an endpoint prepared, we can do the testing of the API, but we can also do a short script that tests the performance of that endpoint and put it on the pipeline. Well, this is an analogy with the Cohen pyramid. I know that if there are people from test automation, for sure they know it. But imagine if we do that, we are at the API service layer. Our tests are going to be cheaper because they are easy to create. We will have early results. We can test it more frequently because if we add it to the pipeline, but we have no idea about the user. And this means, and imagine that because we are not testing with a user perspective. So that's why we have to do this. We should do this, but we also need to test as we do before the release, where we test different things. We have user metrics, user-focused design of the script, because this is where apply the think time, and that part in an early instance at the service layer is not needed, that part. And the scripts are more long because we emulate the behavior of a user, so they are more expensive. And something that we have to take into account. In the upper level, the infrastructure should be similar to the one that we will have in productions, so we can trust in the result that we have, the response time, and so on. But here, if we are testing the API layer, it's not need to have the infrastructure, because the goal is not to see that the load that they able to manage the number of virtual users that we are testing. The idea here is to look for degradations in the response time. So it's a different focus, just looking for that. So that's more or less the idea of the shift left. Start doing scripts that test the performance at the service layer. When we have an endpoint, we can create a script. This is an example of a very simple script that we can do. This was created with K6. So here we have the endpoint. This is a random one that I took from internet. I check the result. I check that the HTTP status code is 200. So this is the only thing we need. If we have a post or something else, for sure we are going to we should create a header and so on, but it's simple. And something interesting about K6 is that we can convert from the Postman collection to K6 script. So if we have the Postman collection, we just have to use a tool and convert, and we can convert all the collection into a K6 script. And this is an example of the stages. I told you that we have a ramp up, then we have to maintain the load, and then the ramp down. Well, this is an example. Target 10 virtual users. It's going to take 20 seconds to get to 10 users. Then it's going to maintain the load for about 10 minutes, and then it's going to decrease to 0, the ramp down, in 20 seconds. This is, as you can see, it's very simple to create the load here. And then we have this threshold that are like, imagine that the checks are like the assertions in test automation, because you can validate a result. And the threshold is more related to the SLA, service level agreement. So we can say that HTTP errors should be less than 2%, 95%, percentile 95 requests should be below 500 milliseconds. That could be something that we have in our SLA, or maybe we define that if we don't have it in an SLA. So as you can see, it's very simple to create a script to generate load in an endpoint. Let's talk about shift right. Should we test on production? Take this into account. If we don't test on production, our users are going to do it anyway. So if we have the chance, I know that in many projects it's not possible to test in production, but if we can, we should do it. Why? Before going on production, everything we can do are just assumptions. It's what we are expecting. And also we have an independent environment that is not going to be connected to different, maybe other applications and so on. But in production, in real life, we have the real world. We will have, there's no assumption there. It's the reality. So we can see the behavior of the users. We can analyze that. We can see some particular behavior that maybe generate possible performance scenarios. We can do this with, for example, Google Analytics, this kind of tool that provide us information about the behavior of the user in the system. And also we're going to be sharing the environment with users and maybe some other integrations. So it's different. But if we have the chance to do it, we should test on production. If we see that something could affect the performance. So we should be aware, we should monitor what is happening on production, and then define if we have to do some performance testing on production. I know it's not simple. I know that it's complex. Maybe we can do it during the weekend. It's going to depend on the project. Not always we can do performance on production, but if we can, we should take this into consideration. Well, I don't want to extend too much because we don't have much time. This is a list of benefits of continuous performance testing. Risk-based feedback, continuous testing makes sure software features are ready for use before they are released. Well, this is something very important for me because I have to face issues that we couldn't fix because we were at the late instance and the stress was so big. Yeah, so I can be sure that this is very important. Smart release decisions, more efficient testing, more stable user experience, integrated team. Well, this is related of what I talked before, that performance testing is not an isolated activity. It's a multidisciplinary activity because we need from other peoples in the different areas, infrastructure, architecture, operation, database, DevOps, and so on to work. And we learn a lot, and I really like that part when we are not at the end of the project, right? And there's an article that I am going to leave you the link of this that explain more in detail each of these parts. Well, and there are some drawbacks on continuous performance testing. It's not always easy to automate. We know this. We cannot load test everything the same as in test automation. We cannot automate everything. Or maybe we can, but it's too expensive. And well, they are scripts, so we need to keep them up to date. So they need maintenance also. So those are the drawbacks that we have with continuous performance testing. So at the end of the day, where we have to test, the idea that you can find in this article of Dan Ashby, Continuous Testing in DevOps, is that we should apply testing everywhere, in every instance if we can. Not only for manual, it's also for performance testing. We cannot do it everywhere, but the idea is to try to do it because we will have a better release if we do it. Okay, and lastly, I want to introduce K6, this tool I showed you the script before, a simple script. Something about K6 is, as I said before, it's an open source tool. It was written in Go, the programming language. This programming language have the advantage that it works very well with threads, and this means that can generate much more load from a single computer than, for example, JMeter with Java. It's very minimalistic, very simple, the code, and you can add features if you want to add your custom metrics. If you want to add different things, you can just look them in the plugin library that they have, and you can also look for it in the community, or maybe you can create your own plugins for this application. So they provide you all the documentation so you can do it. But also K6 belongs to Grafana, so there's a company behind this. And every time that I need some information, if I couldn't find it in the community, then the company can answer your questions. So that's great. It's a command line tool, so there's no IDE. So that's why I put here that it's developer friendly. The scripts are written in JavaScript. So if you come from Cypress in test automation, it's going to be very easy for you to learn how to use it. Then we have the checks and the threshold because it's goal oriented. I talked about this before. The checks are like the assertions in test automation, and the threshold is more related to the service level agreement. Include a recorder also in the if you create an account in the web page, you can use a plugin for the browser where you can record your activities, and then you can use an editor to do some judgment. So it's very simple to use, and we have the tool to convert the Postman collection into K6 script code. And more features. I'm not going to expand too much talking about this. So, well, we have a couple of minutes. I'm going to show you real quick how it works. You should be seeing Visual Studio Code. This is the same script that I show you in the PowerPoint in the presentation. I'm just going to run this. So to run it, we just have to put K6 run and the name of the script. But here I'm going to be sending the output into a database, an influx database, and then I'm going to show you, we're going to take the data from Grafana so we can see it in real time what is happening with the script execution. So I'm going to execute it. And we're going to move to Grafana so you can see how it goes. This is Grafana. I set here the last 15 minutes. It's refreshing every 5 seconds. So we can see here how it is increasing the number of virtual users. Should get to 10. It was going to take 20 seconds to get to 10. Now it's going to maintain. We have here the request duration time. And here we will have this graphic, the request duration over the time. That this graphic shows us, we can see it in real time what is happening. So that's it. We can have this into our pipeline and check what was happening. This is the summary. What we have in the middle is the summary. The media, maximum, minimum, but we are always going to look into this kind of metrics. Percentile 95, percentile 90. We can trust more in this kind of metrics than in the average or other metrics. This is the metric that we should have to take into account. Then if you want, I'm going to send you a link that explains why we have to look at this kind of metrics and not the average, because the average could lie sometimes. And that's it. I don't know if you have any question. I'm going to stop. I'm going to leave this.
Thank
I don't
you,
know.
Diego. I'm checking here. I asked if there were questions and they would write them. I don't see questions, but it's now if you have any, you can ask any type about K6, about any of the other topics.
As I said in the beginning, the idea of this Tech Talk is to show you that it's a good idea to start doing performance testing in early instances of the development life cycle. So if you have any question about this, just let me know. But well, my goal would be, my dream would be that you can ask for this in your current project, and maybe you can save some headaches in the future.
Hi, Diego. This is Ignacio from Include in Real Project. Just one quick question. In the example we are seeing now, you have to increase the users up to 10 in 5 seconds and then maintain 10 users for 5 minutes and doing requests. Those 10 users are the same or are renewing new? They maintain the number in 10 and are the same users. You don't have logins, logout, but you can also tweak that.
Yes, you have 10 instances of user executing the same. Let me show you real quick. Yeah, we have the 10 users here. Every user is going to execute this request. It's going to wait for 500 milliseconds, and it's going to do it again. So we will have 10 users doing the same. Every half second is going to be hitting the API. This is, it will depend on the project, what we can set as number of virtual user and the time we're going to use. We should maybe do some tests to see what we can do there, which number of virtual user we can use. But yes, that's the idea. So now we have concurrency of 10 users hitting the server twice every second.
Okay, thank you.
Another question there, which tool do you recommend us to start learning? I think he's recommending K6, right? Or
yeah, the good thing about K6 is because there are some other tools in other different languages, in Python, but I like this one because fits with with this kind of testing along the whole life cycle of the development, and not the development life cycle, the life cycle itself, because we can test on production also with this tool. And because it's very easy to create simple script, and also the developers can create the script to test their APIs while they are ending the development of each API. That's why I like it. And also because JavaScript, well, we know that Cypress is one of the test automation tools that is growing and growing. And JavaScript is the most used language in the world. That's why I like it. In the projects I've been working, fortunately, the test automation team worked with JavaScript, so it was easy for them to help me with the scripts.
Then the other question, is there a free version of K6 just for learning purposes?
Yes, as I said before, K6 is free, it's open source. We can use it locally. If you use the cloud version, you will be able to do 50 execution for free. You can use the recorder, and it's for free. You're going to use it online because when you record the script, it's going to appear in your account in K6. But if you don't execute it, there's no problem with that. You are not using your 50 tries.
Thank you, Diego. Thank you, Federico Supel Martinez. Any other questions? We also want to invite you, if you have any topic you want to present for another knowledge sharing session, just let us, me, Ostap, Ivan know, and we can arrange. If there's a topic you think will be of interest to the rest of the QAs, that we can learn and set up just short meetings like this, at least to trigger and to share what we know. And do not assume, so if you know something, not necessarily everybody else will know. So probably it's not news to you, but it's news for somebody else. So let's continue working together. That'll be fun. Thank you very much, Diego, for being the first brave one of us sharing. Nice meeting. And yeah, thank you everybody else for joining, and we're looking forward to working together in future projects and to see you in future chats.
Thank you, Ari. Thank you all for joining.
Thank you.
Thank you. Bye, Diego.
Thank you. Bye.
Have a good day.
Bye bye.
Great day.
Thank you.
Bye. Thank you.
Julia, we'll see you in
Bye.